For this part, we're asked to find how many sets of 3 points can be selected which can form the vertices of a triangle. So there's a couple of ways we can think about this. We can think about including P as a vertice and then adding that to all the triangles we can make that don't include P as a vertice. So if we think about including P, so if we include P, then P is definitely a vertice, and then on the blue line, or line 1, we've got 4 points we can choose for our second vertice. Then our third vertice on line 2, we have 3 points which we can choose from. Now, so that's all the triangles we can make that include P as a vertice. Then if we don't include P, so we don't include P, then there's 2 ways I can do that. I can pick 1 point on line 1, that's not P, so just the blue dots there, and then 2 points on line 2, or I can pick just 1 point on line 2 and then 2 points on line 1. So if we think about picking just 1 point on line 1, well, I've got 4 points I can choose from because we're not including P. So we've got 4, and then we need to multiply that by the number of ways I can select 2 points on line 2, which is just 3, choose 2. And then our final way of doing this, we can select just 1 vertice on line 2. So there's 3 I can choose from, and multiply that by the number of ways I can select 2 vertices or 2 points on line 1. So there's 4, choose 2 ways of doing that. So working all that out, we just get 12 plus 4 times, well, 3 choose 2, we worked out before, 11a part 1, which is 3, and then 3 times 4 choose 2, and 4 choose 2 is 6. So then we get 12 plus 12 plus 18, which is equal to 42. Okay, so there are 42 sets of 3 points which we can select, which form the vertices of a triangle. So when we get these combination or combinatorics type questions, sometimes it's good to be able to count these things in different ways. So I'll just show you one more way that we could have counted this one for 11a part 2. We could have just selected all the ways of selecting 3 points. So altogether, we've got 8 points, and we need to choose 3 of them. But we can't have 3 points on the same line if we're going to make a triangle. So we need to subtract all the ways that we can select points, 3 points that are on the same line. So if we select points on line 1, if they're all going to be on the same line, well, we've got 5 points that we can choose from, and we need to choose 3 of them. And then also on line 2, well, we've got 4 points of which we choose 3 of them. That would be the number of ways that we choose all the points on line 2, for example. And working that out, it's going to get 8 factorial over 5 factorial times 3 factorial minus 5 factorial over 2 factorial, 3 factorial minus 4 factorial over 1 factorial times 3 factorial, and working all that out, that is just going to be 56, which is 8 choose 3 minus 10, which is 5 choose 3, and minus 4, which is 4 choose 3, and that also equals 42, which is what we'd expect, of course. Okay, so there are 42 ways that we can do that.